Precalculus lesson 15.4. The last lesson of the textbook, though we are going to circle back to a little bit from chapter 14. So, not technically like the last lesson that we have for the whole year, but yeah, last lesson of the textbook. This is the quick and easy way to do an integral, at least quick and easy relative to the long way. I think you'll find it pretty straightforward. So, again, it's 15.4 called the fundamental theorem of calculus. And just cutting to the chase is this. It's that the integral from a to b of f of x dx equals capital F of b minus capital F of a, where capital F of x is the antiderivative of f of x. So yeah, to evaluate an integral of a function, find the antiderivative of the function, and then do the antiderivative with the ending x value plugged in minus the antiderivative with the beginning x value plugged in. And there are essentially, well, two different ways of categorizing integrals: indefinite versus definite integrals. So you can say indefinite integral would look like the integral of f of x dx. So notice there's no a or b. And what is that? That is just capital F of x. It is the antiderivative. In other words, when we're not given a starting and an ending x value, we're not finding an actual numeric answer for what the area under the curve is. We are instead finding the formula that would allow us to easily solve for the area under the curve. And the formula is the antiderivative. Okay? And then what we have up here, this would be solving for the definite integral. So indefinite is just the formula, the antiderivative. Definite, you're actually plugging in values and getting an answer. All right, let's do some examples. I'm going to use our lesson 3 problem. So first of all, let's evaluate the integral from 0 to 6 of x squared dx. Okay, so we need to start out finding the antiderivative. And you might recall, do 1 divided by, well, the coefficient, in this case 1, the coefficient divided by the new x power, x to the 1 power up. So this is going to be 1/3 6 cubed minus 1/3 6. I guess technically I should do the whole. I'll tell you what. Hold on a second. I'm going to take one step back and say this. So first let's say this. Capital F of x is 1/3. That's not a very good 3. Is 1/3 x cubed plus c. Okay, now we can evaluate this. So we can say that the integral from 0 to 6 of x squared dx equals 1/3 6 cubed plus c minus 1/3 0 cubed plus c. Okay, let's see what that is. That is 1/3 6 cubed is 216. 1/3 times 216. And we have this plus c. and then this minus c. So all the c's end up going away. And then we also have a minus 1/3 of 0, so 0. And so what do we get here? Was that 72? Yep, 72. Boom, that's your answer. Let's do the other example we had from lesson 3. This was evaluate, it was the integral from 1 to 3 of x squared plus 3x, let me double check, x squared minus 3x plus 4. X squared minus 3x plus 4. Okay, well, let's find what capital F of x is. That is going to be a 1/3 x cubed minus 3/2 x squared plus 4x plus c. Okay, so now we plug it in with the ending x value first. I'm going to do brackets this time to separate the two. So 1/3 times a 3 cubed minus 3/2 times a 3 squared plus 4 times 3 plus c minus 1/3 times 1 cubed minus 3/2 times 1 squared plus 4 times 1 plus c. And what do we get? 1/3 of 3 cubed, that's the same thing as 3 squared, so that is going to give us 9 minus 27/2 plus 12. I'm going to get rid of that. The plus c minus c cancels. That'll happen every time. Minus 1/3 plus, because it's minus a negative, 3/2 plus 4. And if I combine my halves and thirds and numbers, so 9 plus 12 is 21, plus 4, we have 25. 25, and then what do we have in terms of halves? So we have minus 27, 26, 25, 24, minus 24 halves, that's minus 12. I'll go ahead and write as 24 halves just so it's easier to see. Minus 1/3. And so that's the same thing as 25 minus 12 minus 1/3. And that is 13 minus 1/3. And that is 12 2/3. 12 thirds, 12, 24, 36. 38 thirds. I think I made a mistake. What did I do differently? Was the original problem? Yep, the original problem was from 1 to 3 of x squared minus 3x plus 4. X squared minus 3x plus 4. So we have 1/3 x cubed minus 3/2 x squared plus 4x plus c. Good. 1/3 3, and it was from 1 to 3, right? From 1 to 3. Yep. 1/3 times 9. Good. 27/2. Good. So 4 times 3 is 12 minus 1/3 minus a negative 3/2. Minus 4. There we go. That's my mistake. Minus 4. So that would make this a 21. 21. Nope. Other way. 9, 21, 17. 17. And 17 minus 12 is going to be 5. Oops, 17 minus 12. That's going to give me 5 minus 1/3, which would give me 5 thirds would be 15, 14 thirds. Cool. Same thing I got last lesson. And then finally one where it's an indefinite integral. We could just say like find indefinite integral of 7x cubed minus 3x squared plus 4x plus 1 dx. So the answer is just my indefinite, or is just my antiderivative. So this is going to be 7/4 x to the fourth minus 3/3 x cubed, so it's just an x cubed, plus 4/2 x squared, so that's plus an x, plus a 2x squared. 2x squared plus 1 over 1 x to the first, or just plus x, plus c. That is my answer. And you can always check your answer by take the derivative of what you just found. 4 times 7/4 is 7, and then drop the power x cubed minus 3x squared plus 4x plus 1, and then the c, the constant goes away. So there you go. That is lesson 4. Nice and, yeah, it should be a nice and refreshing lesson after lesson 3. All right, still, though, let me know if you have any questions.